All right, so today we are, like I said, starting the first half of 1.6. 1.6 is all about angles, including how to measure them with the tool called a protractor. That's what we're going to do tomorrow. So we're going to do the definitions, we're going to talk about naming angles, angle measures, how to classify angles. We're going to do all that first, then you'll have an assignment on that. Tomorrow when you come in, we're only going to do 2 examples together. We're going to use the protractors. It looks like it looks kind of like an upside down U with like a straight side. Okay, so those are what we're using tomorrow. Today though, we're kind of, like working through the less hands-on stuff. Tomorrow we'll actually do the measuring with those tools, okay? So it's all about angles and their measures.
Wait, can we go back?
Sure, I would love to go back for a second. So the first vocabulary word, you'll hear this all the time in this class, is angle. An angle consists of 2 rays that have the same endpoint. So if I have this endpoint and a ray going this way and a ray going this way, that's an angle. We call this part right here the vertex. All right, so we're going to practice how to name angles. Now I'm going to show you one off to the side that's a little different. Sometimes you'll see just one angle like this. Let's just say this was ABC. You could name that angle using one letter. That letter has to be the vertex. So you could call this angle, angle B. If you put that in your notes, great. If you don't put it in your notes, it's fine too. We cannot use just one letter on this example because if I said angle Q, there's actually 3 different angle Qs. There's PQS, there's SQR, and there's PQR. So if there is only one angle at a vertex, you can name it with the angle symbol. Looks like this. It's like a tiny angle and the one letter that's at the vertex. However, that is not going to work here. What's going to work here is the 3-letter approach. When we use the 3-letter approach, the vertex letter has to be in the middle. So if I want to name the top smaller angle, I start out on the ray. The first letter I see is what? P, then Q, then S. So this would be angle PQS. Perfect. Now there's another small angle. Starts where the other one stopped, goes where? S, Q, R. That is the other way. Well, same way, but the other angle. Now, here's where it gets tricky. There's an additional angle there. P, Q, R. So that's why we couldn't just say angle Q, because there are 3 different angles at angle Q. Okay? So again, you start out on the ray, you go to the vertex, you go out the other way.
Now on your homework it will ask you, and on the test, for like the measure of angle PQR or SQR. I would trace over it with your pencil so you double check what you're looking for. Because I feel like that's commonly missed. Because people just look at the picture and don't know really which angle they're actually looking at. Does that make sense? So just like kind of draw over it how Miss Munden did it.
And if you want to use our highlighters or crayons for that too, you can. That's why all that stuff's always up there. You don't even have to ask, just grab it. Okay? Just remember, you start out on a ray, into the vertex, out the other ray. Now, I want to show you one other thing that might happen. Sometimes you will see a little number inside of an angle, like a 1 or a 2. If those are there, you can use that number as well. So if I wanted to talk about PQS instead of writing angle PQS, I could write angle 1, since the tiny 1 is inside that angle. Or if I wanted to talk about angle SQR, I could call that one angle 2, since there's a tiny 2 inside the angle. Kind of like this option up here, it doesn't always work out that well. Sometimes there aren't numbers in there. If there aren't numbers in there, you can't add them. But if you do see a tiny number inside an angle, that's another way to name the angle, okay? Any questions on this example? Now, I will also say, sort of like with the segments, how you could flip-flop the order of the letters, you can do that here too. PQS, you could also call that angle SQP, and it would be the same thing. So lots of variations on naming angles. What are your questions so far? Don't have any. All right, couple more vocabulary terms. Degrees, that's how we measure an angle. The cool thing about degrees is it's similar to like weather, like 85. You see that little guy, degrees? The symbol's the same. Okay, so we use that little circle in the upper right-hand corner to show degrees. And then the word congruent is the same as it was yesterday. Congruent segments are segments with the same measure. Congruent angles are angles with the same measure. And here it is, officially typed out, the congruent symbol that you've seen a couple times already. All right, so the first type of angle we're going to talk about is if it measures between 0 degrees and 90 degrees. And that's called an acute angle. So an example of an acute angle is just a little bitty angle like that, okay? So a 0 degree angle would be like 2 rays right on top of each other. As you open it up, you're making an acute angle. If you open it to look like, let's say, the corner of a door frame, that perfect little angle right there, that's a 90 degree angle. We call it a right angle. I like to think it's just right. So these are little cute angles. A cute little angle. These are angles that are just right. Now, if you think of it as that hinge at 90 degrees, if it keeps opening, if it gets bigger than 90, now you're at an obtuse angle. So drawing like just a big old, like a fat angle, okay? And then if you keep going, you end up with just a straight line. We call that a straight angle, and those measure 180 degrees. So it starts at 0, kind of like the baby shark, you know, opens, that's acute, right, obtuse, and then opens all the way up to straight, okay? And it all depends on the degree measure. Any questions? All right, so as you're writing these in your notes, for example 2 and example 3, remember what we highlighted at the beginning of class today. We highlighted the segment addition postulate. It says if you have 2 smaller segments, you can add them together to find the measure of the larger segment. That happens with angles too. So like on this first one, if I take, and when we're talking about angle measures, we use a tiny m in the front. If I took the measure of angle PTN and I add it to the measure of angle MTN, that should give me the measure of the whole thing, MTP. This is the exact same thing as the segment addition postulate. That's why I'm not making you write it again, because I think you already have something very, very similar in your notes. Just remember, 2 small segments add together to give you the measure of the larger one. 2 small angles, their measures add together to give you the measure of the larger one. Okay? So on this problem, I want to find the measure of angle MTP. So I am going to take some sort of color. Let's say I'm using a highlighter because it's the topic of conversation at the moment. I'm going to trace those 3 letters. MTP. That's the big angle. the big angle is made of two smaller angles. What do you think I'm going to do next?
Put a star.
Find another one.
Add. I'm going to add the measure of the two smaller angles to give me the measure of the larger angle. What are your questions? Now, yesterday, we also talked about if I give you the measure of a larger segment, one of the smaller segments as well, you can subtract to find the other smaller segment. That's what we're going to do here. So same idea. If I am looking for this guy, so the measure of angle CBA, that would be the same thing as the measure of the big angle minus the measure of the other small angle. Okay? So same as yesterday. If I give you the whole thing and one of the little guys, to find the other little guy, you just subtract.
Now,
Okay?
you know you're given the big angle too whenever you see that line, that like semicircle.
Yes, this guy, see that?
Yeah.
Looks like a little.
If you see that, you know you're given the bigger angle.
So that means the whole thing. So if the whole thing is 135 and this little chunk is 60, what do you think I need to do? Subtract. So 135 minus 60. Does anyone know what that equals?
Oh,
What is it? Careful. Just a,
Something else.
yeah, if you're unsure and you don't have a calculator handy, set it up like this. 5 minus 0 is 5. Yep, and then we borrow, we get 13. Correct, so 75 degrees. Now, we're not going to summarize today because as soon as you walk in tomorrow, we're going to check tonight's homework, and then I'm going to shoot example 4 right on the board. So bring these notes back. Bring your homework back. We'll pick up right where we left off tomorrow. Any questions?